Hello again. This is Mr. Kusaj. We're ready to move on to the next section, which is 6F 3D problems. So we're continuing. We're continuing with right triangles. Right triangles everywhere. Okay. 6E, the last section, had to do with right triangles drawn with bearings, north, south, east, west. Right triangles now will be found in three-dimensional figures. Okay, so before we get to our two examples, those would be our notes, just two examples. Let's talk a little bit about drawing three-dimensional figures. So this would be, we're not going to get into the names of them so much as getting what we need from them, which is right triangles. So this is a prism, a cylinder, and a cone. Let me cover them up for a second. For the prism, the best way to draw them would be to draw any rectangle in the front and then a back rectangle that crosses it, but do it dotted, and I'll tell you why in a second. And this should be exactly alike. And then you connect everything. Okay? So in the beginning, just the front is solid. And then what you do is make solid only the lines that are in the front, so that can be seen, that can be touched. So this would be solid, this would be solid, this would be solid. But that would be inside, that would be inside, that would be inside. This can be touched, and this can be touched, right? So once again, the quickest way to do it is two rectangles and connect the corners like that. For the prism, for the cylinder, do not circles but ovals. Actually, it's a circle, but because it's 3D, it's sitting on the table. It'll be like an oval. And try to make one on top of the other exactly alike. And then just connect the sides. To make it a little more visually appealing, what you can do is make the circles dotted like that. Right? Connect with solid lines. And then the front here is solid. The back is not solid. And then we can see the front and the back if we look at it like that. So only the back is dotted. So circle, circle, and then connect. Circle, circle, and then connect. The cone is even easier, right? A circle, and then go straight up from the middle. Go straight up as far as you want, right? As far as you have to. And put a dot there, right? So maybe you can like put a dot here first in the middle, and then just imagine a straight line up, and then connect. That'll be the cone. Okay, something like that. Of course, these are going to be just diagrams that we're going to use to get our right triangle. Okay, so if we look at this closely, lots of right triangles if we draw diagonals. We've seen this before. So if you draw a diagonal on the floor, it'll be a right triangle. If you draw a diagonal on the wall, it'll be a right triangle. And if you think about it, if you draw a diagonal from the ceiling corner to this floor corner, imagine that, that's going to be a right triangle. So lots of right triangles there. Here, you can see it already. If you draw a diagonal from here to here, and then the center, right, the diameter of the circle, and this line would make a right triangle. And this one, if you just drop the height, it'll create a right triangle. Anyway, let's see two of these in examples. Okay, here's our first example. Coffee mug is 90 millimeters high and 73 millimeters diameter. What is the minimum length stirrer that's needed? So a coffee mug is going to look like that. I'm going to draw one of these. And by stirrer is that stick, right, that you stir the coffee with. So if you make the stirrer too small, it'll go inside. So what's the minimum length stirrer? What they're really talking about is the diagonal. So the way I would draw this is like this, right? So this was a quick, sloppy, and I intentionally drew it sloppy because I wanted to show you just to get the idea of what we're talking about and where the right triangle is, right? Circle, circle, connect, and there's my coffee mug. Now, it's 90 millimeters high, so there's my 90, 73 diameter, so all the way across there, and the stirrer would be this diagonal, right? So it can't be any shorter than this, it's got to be longer, so this would be the minimum. We're looking for the minimum. So that's a simple right triangle problem. So we set up the numbers, and etc., and we find that the stirrer, which is the diagonal, has to be a minimum of 115.9 millimeters. Okay? So what we're talking about today is a 3D drawing where we can get a right triangle, a flat right triangle somewhere in there, and then we work with it. So this was pretty straightforward. The second example might involve a little more drawing on your part. Okay, here's the word problem. Airlines don't allow carry-on bags with diagonals greater than 56 centimeters. Kate's bag is 40 by 30 by 25. Is her bag allowed? Right? So, the bag that we're talking about is a cylinder? No, it would be a prism, a box, right? So I put letters on the corners so when we talk about them I can just name them instead of pointing. So what the airlines are saying is, from, if this was a box, the roof corner to the opposite floor corner, that diagonal cannot be greater than 56, right? It cannot be greater. So if it's greater than 56, the answer is no, it's not allowed. If it's less than 56, then we're okay. So how do we find that length? Well, if you look carefully, if we draw on the floor from corner to corner, and this here that's already there, we create a right triangle. So all we have to do is solve this right triangle. But there's no numbers there. Well, it's a box, so we know some numbers. All the way across is 40, back is 30, up is 25. So we know this is 25. But it's true. We don't know this and this, right? So here's what I did. I redrew just the rectangle, just the triangle that we need. Just the triangle that we need, which is ABC, right? This is the triangle we need, ABC. That's what we need. And we already have AB. We already know this is 25. But I can't get AC, which is what we need, until I have two sides given to me. And I don't have this other side, right? I have this 25, but I don't know what this is. So how can I possibly get the hypotenuse? Well, let's back up. Back up. So if we need BC, then let's find the triangle with BC in it. So here's BC. I redrew it here. Hold on. I redrew it here. Here's BC. We need BC, right? I redrew it here. So this is 30. I got this from the word problem, right? 30. And this is 40. So 30, 40, and this make a right triangle. So let me find BC really quickly. 30 squared plus 40 squared is equal to x squared. And we get 50. Okay, again, I did it really quickly, but it's just a simple right triangle. 30 squared plus 40 squared is equal to BC squared. I guess I should have called it x squared, but it doesn't matter. You solve it, then you get 50. So now I know BC is 50. Now, let me take that 50 back to where I need it, up here. Now, all of a sudden, this problem is easy, right? 25, I found this to be 50, and I need this, which I can find very easily, right? 25 squared plus 50 squared is equal to AC squared. That's what we need. Etc. Do the work, and you come up with 55.9. So 55.9 is in fact less than 56. So yes, this bag is allowed. Okay. Okay, so if you were confused by that, we'll go step by step tomorrow when we do our assignment. But basically what happened was we saw the triangle that we needed, and we were missing a part that was needed. So we had this part here, but we didn't have this part. So we backed up and used another triangle to get this part. And then once we had this part, we went back to finding AC. Okay? But even if you're confused, I'm telling you, it all boils down to right triangles. You have to be an expert in right triangles by now. Okay, let me flash all the notes really quick. So this was the first page with the first example. There's a solution to the first example. The second example word problem. The drawing. And the solution. Okay, so tomorrow, if you have any questions, let's go over the questions first before we get to the assignment, and then we'll get to the assignment. All right, see you tomorrow. Bye-bye.